So we have seen what an algorithm is, and it might happen that when you must have solved some problem, and it might have happened that you have three ways to solve a same problem. So we have A1, A2, A3. These are the three algorithms, and all these three algorithms are solving a particular problem. So we are putting the input and we are getting the correct output. Now, how do we decide that A1 is better than A2 or A3 is better than A2? Like, how do we decide that which algorithm I should pick and which and continue further? So, the criteria for choosing a particular algorithm is time complexity and space complexity. Talking about time complexity of an algo is the time taken by the algorithm to execute completely. Similarly, space complexity is extra space required by an algorithm to get executed. Okay. Now let's say when I talk about time taken, that it may happen that a same program, when you okay, you'll say that I have to calculate the time taken, I'll just run it in a particular computer and I'll just calculate the time and I'll measure. But it may happen that a particular program takes less amount of time, or in a laptop which has higher configurations or better configurations, and it may take more amount of time in a laptop with lower configuration. So the time taken or the running time actually depends on the configuration of a particular system. So what do we do? How do we calculate the time complexity? So what we do is we actually decide on a particular system that okay, if I'm calculating the time complexity, is the particular system, and this are the particular criteria that I'll be following. I will discuss the criteria, but before that, let me tell you something. That when I talk about time complexity and space complexity, time complexity is more important. Like a program should run on a in a less time, that is more important than a program is that is taken more memory, because nowadays we don't have a problem with memory, that much of problem with memory, but this time complexity is more important to be taken care of than space complexity. That even in interviews you'll be asked to write a program that has lower time complexity, and it may happen that there are two programs that have the similar time complexity. Then in that case, maybe you will be asked to optimize the space complexity. You might be optimizing the space taken by the program. We will discuss both of them as we go further. So as I said, that if we are calculating a time complexity, we are saying that we are fixing a particular system, and we are like, okay, whatsoever with the program, and when I am calculating the time complexity by myself, I will be adhering to that particular time, that particular system only. So what is that? And I will be following certain criterias or certain measures. So what are the criterias? They are as follow. So I say sequential execution is performed. So if I have a program that int a equal to 10 or I equal to 0, say we have for loop here, and we have some statement here, and then we have some statement here, then the statements will be performed sequentially. It will not happen that I will write this thing and I will execute this first. So what happens is, when we write a program, so when we are calculating the time complexity by ourselves, we don't do this that okay, this will get executed first, then this will get executed. It has to execute sequentially. Next we have, so every arithmetic and logical operations will take 1 unit of time. This is what we assume. So these are the assumptions based on which we will calculate the time complexity. Next will be 1 unit for assignment and return. 1 unit for read and write ops. So we say that whenever we see an assignment or a return, so 1 unit will be consumed there. That particular statement will take 1 unit to get executed. Similarly, if we have some read or write operation, it will take 1 unit of time. Similarly, similarly we have for arithmetic and logical operations. Let's see a very small program. So this is a small program, and if I am asked or to how to calculate the time complexity, or what will be the time taken for this whole thing to get executed, I see that there is only one statement that is written a plus b, and we know that this a plus b will take 1 unit of time, since we saw that a logical operation or an arithmetic operation takes 1 unit of time, plus we want to return this value as well, so that will also take 1 unit of time. So this particular uh, program takes 2 unit of time. Now what happens is, as you can see, that no matter what is the value of a and b, no matter whatever could be the value of a and b, this will always remain 2. So in this case, this a and b is the input, and no matter what is the input, this remains constant. This unit of time consumed or taken won't change. So such is called constant time complexity. So what is constant time complexity? When the time taken by the program to get executed, or the time complexity of a program, does not depend on the input. So let us take one more example to see that what do we mean when we say that it depends on the input. What is such kind of program? So now let's try to see that what will be the time complexity, or what will be the number of operations that will be executed in this particular code. So this is an assignment, so it will take 1 unit of time. This particular will take 2 plus 1 unit of time. I will let you know why I've written 2 plus 1. This will take 2 unit of time, one for the addition and one for the assignment, and this will again take 1 unit of time. This I am considering when n is equal to 1. This loop will run only one time. So what will be the total time taken? Why did I write 4 plus 3? Because these ones, like this, will be executed only once in the whole code. This will be executed only once in the whole code, and similarly the sum will be returned only once. So what happens is, when n is equal to 2, this 3 remains constant. What is the number of times this loop gets run? 2. And each loop, running of each loop takes 2 unit of time. So the time taken to run this particular statement when n is equal to 2 is 2 into 2. This is the number of operations that is getting executed in each loop, and this is the number of times loop is running. Similarly, this takes 2 unit of time, and for for n equal to 2, it will take 2 run. So the total time will be 2 plus 2 plus 2 into 2. Sorry, 2 into 2 plus 2 into 2. That is 3 plus 8. Now when n is equal to 3, what happens? Again this 3 remains constant. This loop will run 3 number of times. So, and the number of times and the number of operations in each run is 2. So the total time taken by this particular loop will be 3 into 2. This is the number of times loop is running. This is the operations. And similar is the case with this. This will also take 3 into 2. So this will be 3 plus 6 plus 6, 12. So we see that if we try to generalize it for n, then again 3 remains constant. This for n, this will run n number of times, and each run will have 2 operations. Similarly, this will also run n number of times in case of a loop, and each operation takes, and there are 2 operations, so it will be 2 into n. So total time taken will be 3 plus 4n. So we say that this is the time complexity, where n here is the input, because this is a variable, this is not constant, and based on this particular time complexity is changing. When n is equal to 1, less time will be taken. When n is equal to 100, more time will be taken. So we see that the time complexity depends on the input, and we also see that this is linear time complexity. So as the input size increases, time increases linearly. Now what happens is, we see there are many constants here, and what happens is when n is really large, say n is 1000, so it will become 4000, and this particular 3 won't have much of significance in this case. So what do? We ignore this. So what we do in case of asymptotic analysis, we ignore the least significant terms. So this is one case, so let's take another example. So this is another code. Let's try to calculate the number of operations and try to find the time taken or the time complexity. So what happens is, again, let's say when n is equal to 1, this gets executed one time, this gets executed one time. Let's first see and what is the number of times this particular loop is getting executed. We multiply it with the number of operations accordingly. When n is equal to 2, this gets executed, 2 into n number of times. Sorry, it gets executed n number of times here. And when n is equal to 3, this gets executed 3 times, and this gets executed 3 into n number of times. If we try to generalize for it, then it gets executed n number of times, and it gets executed n into n number of times, which is n square. Now let's see that in each run what is the number of operations that is happening. So this is 1 plus 2 into n. For each run 2 operation is happening, and in this case also it is running, as we saw that it will get executed n square number of times, and this will be the number of operations. Similarly, this will occur n square number of times. So if we try to calculate the time complexity, it will be 1 plus 2n plus 2n square plus 1 plus n square. It comes to be 3n square plus 2n plus 2. Now again, as I said that in asymptotic analysis, what do? We take the most significant thing and we ignore the less significant numbers. Again, the reason for this is when n is very large, then these numbers will have least significance or least value in front of this. We saw in previous example that the time taken is this. Now if we put n equal to 100 here, and as we saw that asymptotic analysis is something in which we ignore the less significant numbers and only take the most significant number. Why is that? Because for when n is comparatively very large, this values will be very less compared to this. Let's take an example that when n is equal to 1000, in that case this will be 1000 square, this will be 200, and this will be, as you can see that this number is very large as compared to this particular number, and when n keeps on increasing, this becomes larger. So what we do, we ignore this less significant numbers because the time very much depends upon this more significant amount. Now what happens is, to represent a time complexity, actually we need a notation, and we have asymptotic notations. So we have, let's say, asymptotic notation. They are nothing but just the mathematical representation of time complexity. So, and further, asymptotic notation are of 3 types. We have big O, we have big omega, we have big theta. Okay. So these are the 3 asymptotic notations, 3 ways to represent a time complexity. Let's discuss them one by one. Before that, what happens is when you run a program, let's say I write a very small program. We have an array A, let's say A an array, and I want to search for a particular element in an array. So let's say I want to search 6. So what I'm doing is I'm running a program, and I say that when a of I is equal to 6, return. In that case, the program gets stopped when it finds 6. It may happen that if this is an array, it may have size let's say 10,000. Then 6 is just here. At the third place 6 is there. This is, or let's say first place, we have 6 at the very first place. It is very nearby, it is very at the very beginning. So what happens is the loop will run only 3 times and the program will be over. So what do we say? This is the best case. This is the best case scenario that we can expect. This will take least amount of time. Now it may happen that when we have n is equal to 1000, the loop is of size 1000, and this particular element 6 is present at the very end of the array. In that case, the whole loop needs to get executed and the time complexity will be worse in this case, because this is the worst that we're expecting, that will be at the end. Or it may happen that the element is not there in the array, then also the whole array will traverse. So this is the worst case that is happening. We say that this is the worst case. And now it may happen that 6 is somewhere in the middle of the program, sorry, array. In that case, we said that this is the average case that we have. So we have worst case scenario, we have best case scenario, and we have average case scenario. And each of these have some relation with this scenarios. Let's try to discuss each of these one by one. First, we have big O.